Before we dive in, my sweet angel, Winnie, my dog, was a little wound up before I started, so she is quietly behind me watching The Big Bang Theory. I hope the noise doesn't interrupt the video. I'll try to talk over it, okay? She settles down if she has something to watch on TV. Okay, so for chapter 7, we're going to start talking about equations in two variables. And what is interesting about equations in two variables is we typically solve them by graphing, okay? So in order to kind of get an understanding for the solution to an equation in two variables, we need to see the visual representation of that equation. Okay? So the very first topic well, first of all, in section 7.1, we're going to talk just kind of generically about graphing and then functions. But specifically for topic 1, we're going to talk about where we graph those equations in two variables. Okay. So topic 1 is the rectangular coordinate system. Okay. Now, at this point, you should know that I like to start things out with a nice definition. So for this worksheet, our first definition is that of the rectangular coordinate system, okay? So the rectangular coordinate system, also called the Cartesian plane, and I do want to tell you, I typically call it the Cartesian plane, okay? This is a two-dimensional plane that consists of two number lines that intersect at right angles, okay? So it's just this kind of like, you can think of it as a grid, but it's just a plane that we can represent equations in two variables, okay? And just to be clear, the equations in two variables, the variables are going to be x's and y's typically, okay? Now, we need to kind of understand what the Cartesian plane looks like, okay? So we're going to sort of describe and define different components of it, and then we're going to label it, okay? So you can see here on the right, I have this grid. We have two number lines that intersect, forming right angles. This is an example of a Cartesian plane or the rectangular coordinate system. You will also have people sometimes call this the XY plane. All three of those, the rectangular coordinate system, Cartesian plane, and XY plane, they all mean the same thing. It's just a two-dimensional place where we can graph equations in two variables, okay? So as we go through these definitions on the left, we'll label on the right. Okay, so components of the Cartesian plane. First and foremost, by definition, we have up here that the Cartesian plane is a two-dimensional plane that consists of two number lines that intersect at a right angle. Well, those two number lines are the x-axis and the y-axis, okay? So the horizontal number line is called the x-axis, and the vertical number line is called the y-axis. And this is something that you must learn, understand, know, and memorize, okay? So this is the x-axis. This is the y-axis, and they do intersect, forming right angles, okay? Now, the point where the x-axis and the y-axis intersect is called the origin, and that's another really important piece of information. These definitions, you really do need to know them kind of inside out and backwards, because we're going to use this Cartesian plane from now until really the very end of the semester, okay? So the point where the two lines intersect right here, this is the origin, okay? Now, the next definition, we have the Cartesian plane consists of four regions called quadrants, okay? So hopefully you can see here, we clearly have four different regions, okay? So starting in the upper right-hand corner, okay? So in the upper right-hand quadrant, and then moving counterclockwise, okay? We label the quadrants 1, 2, 3, and 4. Now, we do typically use Roman numerals. Now, I'm probably older than most of you, and when I was a kid, we learned about Roman numerals in class, okay? I don't have time to do like a deep lecture, but just know if you have what looks like a capital I, that stands for 1. If you put two of those side by side, that would stand for 2. If you put three of them side by side, that would be 3. And then this is where it gets tricky. 5 is represented with just a V, okay? So instead of writing four ones side by side, what we'll do is we'll write a V with a 1 in front of it, and that represents 4. Okay, so think of it almost kind of as like 5 minus 1 is 4. So when you have that 1 in front of the V, it means 1 less than 5. Okay, so this is 1, 2, 3, 4. And we don't need 5 because there are only 4 quadrants, but the V on its own is a 5, okay? So starting in the upper right-hand corner, This is quadrant 1. Okay, and a lot of times you'll put the lines on top of these like so. All right, and then moving counterclockwise, we have quadrant 2, quadrant 3, and then finally quadrant 4. And the order is non-negotiable. That is how we label the quadrants, okay? So there you have it. That is the x-axis, the y-axis, the origin, and then the 4 quadrants. I do want to point out that the origin is kind of like home base. So as we move away from the origin in the right-hand direction, we're going positive on the x's, and we're getting bigger. As we move to the left from the origin on the x-axis, things are negative and getting smaller. And then from the origin, as we move up, things are positive and getting bigger for y. And then as we move down on the y-axis, things are negative and getting smaller for y. Okay, so kind of understand that origin really is like home base. To the left is negative, to the right is positive, down is negative, up is positive. Okay, so that is just the basics of your Cartesian plane. In the next video, we're going to talk about how we represent locations on the Cartesian plane. We use something called ordered pairs.